So what we're covering for today, we are talking about slope, how to calculate slope from a graph. So we focused on it quite a bit yesterday when we talked about slope and the triangles, how basically the idea of slope is creating these right triangles. As you're doing a rise over a run every single time, you're essentially creating a series of right triangles from one point to the next. And like we said yesterday, that it doesn't matter where you draw your right triangles, the slope that is created from those right triangles will all be the same. They are not different. It just simplifies to the same value each time. So what we're going to be doing here today is we're going to talk about finding slope from a graph. We're just going to focus on it from a graph today. And then we're also going to talk about this word steepness. So if I were to say something like, that hill is really steep, what do you think that means? If I say a hill is really steep, what do you think that means? I want you to turn and talk to your table. 2, 1. All right, so I'm going to have Guadalupe share because she shared a really great, vivid detail or description of what steepness was like. So go ahead and share.
When I used to live in my old neighborhood, I lived on a very steep hill, and it was like steep like this. And if you were to go to the top and ride your bike, you go super fast all the way down to the bottom.
Okay, so what she's saying that if you have a steep hill, when a hill is really steep, one, it probably takes a long time to try to get up it, right? Yeah. If you're riding your bike up it, you're going to be working hard on this hill versus this hill, right? You're going to be working a lot harder. If the hill's only like this versus like this, you're going to be working really hard. But also, if you're going down the hill, you're going to go a lot faster than if it's like this, right? So steepness just, it kind of gets it to where it's almost a vertical line, right? The more steep a line is, the closer to a vertical line status it becomes. Horizontal line has no steepness at all, right? A horizontal flat line has absolutely no steepness. So you want to make sure you have an understanding of what steep means. What does it mean to be steep? Okay, first thing we're going to do though is focus on finding the slope of these lines. So the first thing we need to do is identify some points on the graph. So they haven't given us any points on here. They've just drawn the line. So I'm going to zoom in and we are going to select a couple points ourselves. Now, when we are selecting a point, we want to select a point that is at a good position to where we can see its whole value numbers. Like obviously I would not pick this point because I don't know what the value of x is going to be. It's going to be some kind of decimal. I'm not sure quite what decimal it would be. I want to look for a point that's going to intersect perfectly at these little crosshairs on the grid. So wherever the lines on the grid intersect, if my line happens to go through that point, I want to choose that as a point. So looking up here, I've got several points that I could go with. I could go with this point, which happens to be at the position 3, 3. Paper's right up here, hon.
Oh.
Here. You could go with this point, which happens to be at the position 2, 1. You could go with this point, that happens to be at the position positive 1, negative 1. You could go with this point, that happens to be at the position 0, negative 3. Okay, so these are all points that happen to be on the graph that I could go with. I'm going to show you again that it doesn't matter which 2 points you pick, they will all come to the exact same result when we are finding slope. So remember we said yesterday that slope is calculated by identifying the rise over the run. So we set it up as a fraction. We put the value called our rise on the top. And think rise is what goes up or goes down. Okay, and then our run is going to go on the bottom. It's the values that are going to go left and right. Now, before I begin, who can tell me what kind of slope is this? Is this a positive, a negative slope, a zero slope, an undefined slope? Adonai? Positive. This is a positive slope, so that means that I am going to have a positive answer at the end. I need to make sure I'm having a positive answer at the end. Okay, so I'm going to go ahead and show you from my first point to my second point, but I'm also going to show you what it looks like from my second point to my last point, that they are both the exact same slope. Okay, so from my first point to my second point, I have a rise of how much? Isaiah? 2. I am increasing by 2. So I have a rise of a positive 2. Okay, now my run, again, I'm forming a right triangle here. I'm forming this right triangle. My run is what? What's my run going to be? Guadalupe? 1. It is a positive 1. So my run is positive, my rise is positive. I always set it up as rise over run. So my slope in this case is 2 over 1 or just 2. 2 over 1 or just 2. Now remember, I said it doesn't matter which 2 points you pick. It's going to be the same no matter what. So let's now go ahead. We're going to do it from that second point. We're going to go all the way to the last point this time. So we have a rise this time of how much? How much is that going to be for our rise? Anasia? Let's see. 1, 2, 3, 4. It's going to be a rise of positive 4. It's going up, right? We're increasing. We're going upward. Okay, so we have a rise of positive 4. And then our run, we are going to the right. How much is our run, Brian? 2. Our run is a positive 2. Okay, so again, we now have 4 over 2, but 4 over 2 also simplifies to 2. So our slope, again, it does not matter, just like we learned yesterday. It doesn't matter which 2 points you connect. When they are on the same line, the slope will be the same. So no matter what kind of right triangle you create, those right triangles are similar to each other. They will have identical slopes. Okay, so our slope of this one is equal to 2. Okay, let's do another one together. You can tell me what type of slope. What type of slope is this, Diana? Negative. So that means when I'm saying, hey, my final answer for slope is, I need to say it's negative something. It's going to be a negative slope. To base the direction that it's going in, it must be a negative value. Okay, so we need to find a couple of points on here. Here, I found a point right here. This point is at negative 6, positive 3. So I have a point at negative 6, positive 3. And I also happen to have a point, I have a point right here as well. I have a point at positive 3, negative 3. I have a point at positive 3 and negative 3. And yes, there are points in between it, but I'm just picking any 2 points that I want on this graph. And then I'm going to identify my rise over my run. So we're going to talk about the rise first. The rise is what's taking us either up or down. Are we going to go up? So we always start with the left. We always start from the very far left point. From my far left point, do I need to go up or down? Down. That's where I get my negative from. Because I'm going down on the graph, I get a negative there. So now we need to count how far down do we need to travel to get to the same level as our second point. Okay, so go ahead and count that. How far down do we travel in order to get to that same level as that second point? 6? Let's see. Yep. 1, 2, 3, 4, 5, 6. So we went down. That's where the -6 is going to come from. It's a negative. So our rise is -6. Now we can focus on the run. The run, we now move to the right. And we want to connect to that second point. So we need to calculate how many units does it take for us to connect to that second point. So go ahead and count your run. What'd you get, Isaiah? 9. Very good. And because we're moving to the right, it's a positive 9. We moved to the right. The y, we had to move down. We had to go downward. So that's why we have that negative. But the run is a positive 9. But remember, a negative over a positive comes out to a negative. And then we just need to simplify 6 over 3. 6 over 3 can simplify to 2/3. So we get negative 2/3. Negative 2/3 for our slope. I want you guys to try that third one at the bottom on your own. I went ahead and gave you 2 points already. All right, so let's go ahead and take a look at this. Remember, we're focusing on finding our rise over our run. So for the rise, we always start with the very leftmost point. Okay, in case you can't see it, this leftmost point, this happens to be at 0. And was it 1, 2, 3, 4, 5? 0, 5. And then this right point happens to be at 1, 2, 3, 4, 4, 2. Okay, so those are the points. Now we want to find how they connect to each other. So we're going to focus on our rise first. Who can tell me what the rise is? Aeon? Positive 3 or negative? Negative, right? Because it's going down, right? It went decreasing, so it's a -3. -3. And then our run, what's the run going to be? Natalia? 4. Positive or negative? Positive. Very good, because it's moving to the right. So it's a positive 4 for the run. Okay, then when we just simplify, a negative over a positive is a negative, and then 3 over 4 is actually as simplified as it gets. And there's our slope. Really easy stuff, right, guys?
Yes.
I love slope. I think slope's an easy, fun, simple concept. All right, let's go ahead and turn it on over to the back. Now these should look real familiar to you. Okay, we've got a vertical line, and we also have one that's plotting a horizontal line. And remember, we talked about those last semester. We even talked about it briefly yesterday as a reminder. Who can remind us vertical lines have what kind of slope? Vertical lines have what, Camille? Yeah, the blue one. That's undefined. Very good. So this is an undefined slope. Let's talk about why. I don't want to just say, oh, it's undefined. I want to show you why it's undefined. So we're going to pick any 2 points on here. I'm just going to pick this point here, which is at 2, 2. And then I'm going to pick a point here that's at 2, -2. Okay? So the first thing I'm going to talk about is my rise. So my rise from one point to the next is going, depending on how you see it, you can say it's going up or it's going down, but it's going to have a change of 4. Doesn't matter whether you say it's going up or down because they happen to be at the same position of left or rightness, right? So it has a rise of 4, but its run is nothing. There is no run. The run is 0. We are not moving left. We are not moving right. So the run happens to be 0. Type in your calculators right now a fraction 4 over 0. Type in your calculators 4 over 0 and hit equals. What do you get?
Divide by 0.
you have a divide by zero error because you are not allowed to divide by zero. You're not allowed to have zero as a denominator in a fraction. That is why it comes out as what we call undefined. You are not allowed to have a zero in your denominator. So that comes out or calculates out as undefined. Okay? When we are doing our horizontal, similar concept, I can pick any 2 points that I want. Okay? This time, does it have a rise? No. This time the rise is what's our 0. And the run is anything. It's any value depending on what points you picked. In this situation, my run is 1, 2, 3, 4, 5. My run happens to be a 5. And now if I put 0 over 5 in my calculator, what does that give me? Do 0 divided by 5. Put that in your calculator. Show me what you get. 0. So that's why this is called zero slope. Because if your numerator is 0, then the whole thing comes out to 0. Okay, so this is a zero slope. So these are our special characteristics for slope. Okay? Okay, let's go ahead and continue on. Here, we're going to match each scenario with its graph and the type of slope that it potentially could have. So we're given a scenario. You're going to identify whether that scenario represents a positive slope or a negative slope. So let's take a look. Let's take a look at scenario A. A tank is draining at a rate of 5 gallons per minute. A tank is draining at a rate of 5 gallons per minute. Do you think that's going to represent a positive slope or a negative slope? Negative. What word would indicate negative? Draining. Draining. That's going to have a negative slope. Okay, and then a tank is filling at a rate of 5 gallons per minute. That would have the opposite effect. The word filling, that would represent that it's going in a positive. Camille? No. Okay, let's go ahead and flip it on over to the next page. So now we're going to be talking about steepness. So like we said before, or like Guadalupe informed us, that a steepness, if we're looking at lines, the more vertical that they become, or closer to the vertical that they become, the steeper that they are considered. So we're going to take a look here. Before we identify what the slopes are of each of these, I want to identify which ones do you think are going to be considered the least steep compared to the most steep. So we're going to put it in order of least steep to most steep based off of just the pictures that we're seeing. So which picture, A, B, C, or D, do you think is the least steep? And then put it in order all the way up to which picture do you think is the most steep. I want you to have that discussion with your table for, I'm going to give you about 30 seconds to discuss with your table. All right. Ashley, what did your group decide was the arrangement for steepness? Which one was the least steep graph? B, okay, so B is the one that has the least amount of steepness. Then which one? C, okay, followed by A, and then we end with D. Okay, so we can see the progression. So B, then it starts to move upward a little bit to C, upward a little bit more to A, and then up even more to D. Okay, so those are our least steep range to our most steep. So now let's go ahead and take a look at what their actual slopes are. So again, picking 2 points on the graph. Okay, I have a point right here and right here on my first graph for graph A. So graph A is going up 2, and then it's going to the right 1. So we have a slope of 2 over the 1. 2 over 1 is just going to come out to 2. So if we put 2 over 1, Camille, I need you to, or I'm sorry, not Camille, whoever's talking, please stop talking. not 0, sorry. My apologies. Okay, so our slope is going to be a value of 2. Let's take a look at graph B. Graph B, I have a point right here and right here at the origin as well. Okay, so in this case, my rise is 1 and my run is 3. So I get a rise of 1 over 3, which is just 1/3. Okay, for graph C, I have a point here at -1, -1. I also have a point here at +1, +1. Okay, that means I'm going up 2, and then I'm going to the right 2. So I have a rise of 2 and a run of 2. That comes out to a slope of just 1. Okay, and then for my last one, my most steep, I have a point here at -1, +4, but I also have a point here at 0, 0. So that has a rise of 4 over a run of 1, which just simplifies to 4. Okay, so taking a look here, we said before that graph B was the least amount of steepness, followed by graph C, then graph B, and then the most steep was graph D. So let's go ahead and take a look at their slopes. What do you notice about their slopes? When we put it in order, did the slopes go in order as well now?
No.
Let me ask you, is 1/3 the smallest number? Is 1/3 smaller than 1? Huh? Oh, I put 2 B's. Thank you. Sorry, this isn't A. Is 1/3 smaller than 1? Yes. Is it smaller than 2? Yes. Is it smaller than 4? Yes. 1/3 is our smallest number. Is 1 smaller than the 2 and the 4? Yes. Is 2 smaller than the 4? Yes. So is this in numerical order? Yeah. It's in numerical order from the smallest to the largest. So what we know about steepness is that the bigger the slope, the steeper the line. The bigger the slope, the steeper the line. Those of you who have your computers open, close them now.
Are we not going to do any computer?
I don't know if we are, but they shouldn't be on their computer when I'm trying to teach.
Oh, we always just asking.
Yeah. So the smaller the slope, the more flat the line looks. Okay, the bigger the slope, the more steep the line looks. Now, what if this 4 was a negative? If this was a negative, it still would be the most steep. And here's why. When you're determining steepness based off of your slope, you're going to compare the absolute values of the slope. So you're not focusing on the positive or the negative of it. You're focusing on the absolute value of the slope. So if the absolute value of your slope is the largest number, it is the most steep. So it wouldn't matter if this was a +4 or a -4, it would still be more steep than the other 3 graphs because the absolute value of a -4 is still positive. Okay? So when we are comparing, it's very important that you focus on the absolute values of those slopes. The larger the absolute value is, the steeper the slope is going to be. So with that in mind, let's take a look at these 2 problems down below. We're going to arrange these numbers in order of their steepness from smallest or least steep to greatest steepness. So remember, again, you're going to focus on absolute value. The absolute value, you're ordering those. Okay, so I want you to take a moment with your group, focus on group A and group B, put them in order from least steep to most steep. All right, taking a look. So ignoring the signs, ignore the signs. We're not going to focus on the fact that it's negative or positives. We're ignoring the signs completely. Camille, turn around. We're ignoring the signs completely, and we're focusing on putting them order from, least steep to most steep. So which number up here is the smallest number up here? The 1/10, right? 1/10 happens to be the smallest one. It happens to be a negative, but we're not worrying about the negative. That's just going to be the least steep. Okay, it's going to be very, very close to almost a flat, flat-looking line, almost. Okay, then what happens to be the next smallest number? Disregarding negatives. Don't focus on the negatives. What's the next smallest number then going to be? The 5. Good. Okay, and then after that, it's the what? 7. And then the last one is the 9, but we're going to put the negative. So -9, even though it's negative, it's going to be very, very steep, very close to looking like it's a vertical line. Okay, problem B, we've got 1/4, -1, -1/2, and a 4. So we want to know which one is considered to be the smallest of them without regard to any of the negatives. So obviously these fractions are going to be smaller than these whole numbers, right? So we're really focusing on 1/4 and 1/2. Which one's smaller, 1/4 or 1/2, Diana? 1/4, right? If you think about it, think of a pizza, right? A pizza circular. Is your slice of pizza going to be bigger if you split the pizza in half or if you split it into fourths? It's bigger if you split it into half, right? So a half is bigger than a fourth. So this 1/4 is going to be the smallest, followed by that -1/2, or, for steepness. And then it's going to be -1, followed by 4. So those are the orders for our steepness. Okay, we are done with our lesson.